Hello and welcome to this video tutorial for Puzzle A. Through this puzzle, you will explore a little bit of a mathematical topic called combinatorics and discrete probability with your students. Fear not, no prior mathematical knowledge will be required for you to enjoy exploring this puzzle with your students. This puzzle gives you the opportunity to connect with your students. For example, you can ask them about games they like to play, what kinds of games you like to play, um, to get you to know your students a little bit better. And you could also talk about college life. Like, for example, maybe you could talk about games that students get to play during orientation at UCI. Okay, let's look at this game and discuss how we might guide our students as they play. So this game, we have to complete certain missions, and we want to do it using the least number of attempts to grab an egg, or least number of grabs of an egg. So let's see what we have here. So mission 1, we're asked to get at least 1 dragon egg. And then if we grab 5 eggs, we ask, is it 100% sure that we will succeed in grabbing at least 1 dragon egg? So that is the probability 1 that if we grab 5 eggs, 1 of them will be a dragon egg? Some of your students, you might not want to use like, is it the probability 1? You want to say is like, are you 100% sure that if you grab 5 eggs, that at least 1 of them will be a dragon egg? And then you can start talking about, if your students aren't sure, you can say, well, what's the probability, or what are the chances that when we grab 5 eggs, we don't get at least 1 dragon egg? And you can start exploring that together. That'll give you an idea of if there's a probability of not succeeding. And that might be more illuminating for some students. For example, you could start discussing worst case scenarios, like what if, for example, I draw a blue griffin egg, a white griffin egg, a magic falcon, a megasar, and then the other magic falcon egg. I didn't grab a single dragon egg, so it's sure that, it's surely possible to not grab a dragon egg when you pull 5 eggs. Darn. Well, okay, so it looks like the answer is no. You cannot be 100% sure. And if it's not immediately clear to your students, that's okay. Try to like maybe have them draw chips from the bag to try to conduct experiments to start exploring what are the possibilities. And if they can draw 5 chips that are not dragon, that don't contain a single dragon egg among them, then you could say, well, now we know that there is a chance to fail. So the chance of success is not 100% guaranteed. Okay. Now, mission 2, we want to get at least 1 griffin egg, and there are 2 types of griffin. There's blue and white griffin. We're asked what is the least number of eggs that we need to grab to be sure to succeed. And you want to invite your students to explain why they think that. Maybe they can conduct experiments. Like, say, for example, what if we want to talk about what kind of draw do we need to draw in order to fail? For example, we could draw magic falcon eggs, 2 of them. We could draw 7 of the megasar eggs, 8 of the dragon eggs, and we still don't have to have drawn a blue griffin egg or a white griffin egg. So there are 2 eggs we drew here, plus 8 eggs we drew there, for a total of 17 eggs drawn without drawing a single dragon egg. This is the worst case scenario, but this could happen. And so if we want to be absolutely certain that we draw a griffin egg, then we need to draw at least 1 more egg to get 1 of the griffin eggs, 1 of the blue griffin eggs, or 1 of the white griffin eggs. So if we have 17 plus 1 eggs drawn, that's 18 eggs in order to guarantee we get at least 1 griffin egg. Fantastic. So now hopefully your students are starting to get the hang of it. They start thinking about worst case scenarios, and they start thinking about different choices they make when trying to assign a likelihood to a certain objective. Okay, mission 3, get at least 3 dragons when we draw eggs. Okay, let's think about this one. What is the least number of eggs we need to grab to be sure to succeed? So again, we want to be absolutely positive that we have gotten at least 3 dragon eggs. But this problem is similar if we say instead of 3 dragon eggs, 1 dragon egg. We could start there if maybe 3 dragon eggs seems like maybe your students feel that's too complicated. And then we could always abstract this if your students are really confident and say we want X dragon eggs, where X is between 1 and 8. Okay, so how does this work? Again, we start with a worst case scenario. We draw all 7 of the Megastar eggs, 2 of the Magic Falcon eggs, 10 of the Griffin eggs, 6 and 4 respectively. And we don't have any dragon eggs yet. This is a worst case scenario, but this could happen. So we have 10 plus 2 is 12 plus 7 is 19 eggs drawn and still no dragon egg. So in order to draw at least X dragon eggs, we must then draw X more, which means that we have, if we want to draw X eggs, we have to draw X plus 19 eggs in order to be certain that we draw at least X dragon eggs. Okay, so we've explored the first 3 missions. Let's look at the next missions here. Oh, we want to achieve diversity with this mission. We need to guarantee at least 1 egg of each of the 5 species. What do? So we want to achieve some sort of biodiversity here. And how can you be sure that your strategy will achieve that diversity? Okay, let's start again with worst case scenario. If we draw 1 egg, it has to be one of the species. So no matter where we start, no matter which egg we draw, we've achieved some measure of diversity. So we've drawn a dragon egg, fantastic. But we could be really unlucky, and then the next eggs we draw are all dragon eggs. Oh no. So that means we've drawn 8 dragon eggs and we still haven't achieved our goal. So next, perhaps our next draw is a Megastar egg. Great. We've achieved a second level of diversity in our collection of eggs, but it's possible to continue drawing Megastar eggs. Oh no. So we've drawn 7 more eggs without achieving our diversity goal. All right. Next, after we've drawn 8 dragon eggs, 7 Megastar eggs, we have to draw an egg from a different species because there are no more Megastar dragon eggs left. The next egg we draw will have to be from one of the species we haven't drawn yet. Suppose it's the blue griffin. Now we get unlucky again. We've achieved this new level of diversity, but each of the subsequent egg draws are the same species. Wow, this is awfully unlucky. If you want, you could think about the probability of this particular draw happening or not. That's perfectly okay. Probably don't try and get your students to do it. Okay, next we draw a white griffin. Great, we've increased our diversity, but again, we continue drawing the same species. So now at this point in the game, we've drawn, let's see, 8 plus 6 is 14, plus 4 is 18, plus 7 is 25 eggs. So it's 25 eggs, and we don't have diversity yet. The very next egg we draw is a magic falcon. And that gives us our goal. So we drew one more. So this is a total of 26 eggs drawn in order to guarantee that we achieve diversity. Fantastic. This is interesting. You could maybe encourage your students to reason, like maybe you draw blue griffins first. Does that change your answer? Things like that. Okay, and then you can encourage your students to create their own missions. Like, for example, suppose you want to ask them what's the least number of eggs, or maybe they come up with their own games and challenge themselves in their groups or in their group to draw, what's the least number of eggs to draw at least one dragon egg and one griffin egg. Go. And they can have fun with that. Okay, that's it for this puzzle. Thank you for watching. I'm really stoked about playing this game with you all on Monday, and stoked to see what the kids think on Wednesday, and I'm really looking forward to seeing that. Until next time, au revoir.